My name is Miao, and I'm a professor in the Department of Chemical and Biological Engineering. The technology TAF founded is focused on membrane separation for capturing CO2 from different point sources, including power plant, cement plant, and other plants emitting CO2.
I am Dinesh Kumar Behra. I am a PhD candidate in the Department of Chemical and Biological Engineering at University at Buffalo. Climate change has been a major issue and a major problem recently, especially identified recently. What we try to do is CO2, which is one of the primary greenhouse gases. We are trying to remove those from the atmosphere and basically stop it at the source. A point source like power plant releases these gases into the atmosphere. What we try to do is stop the release and release only nitrogen and use the CO2 either to sequester or to make meaningful products. We can make methanol, we can make various other products like ethanol. We have also started looking at technologies where CO2 is converted into LPG and other fuels, which can be used as a source of energy.
There are many different technologies for CO2 capture from power plant. Like the absorption process, you can use a solvent like liquid phase to absorb CO2 in there and capture the CO2. Or you can use porous materials as an adsorbent. We are using a membrane technology. It's a very thin film to capture the CO2. And the uniqueness of our technology is we can provide super high selectivity. That means you have a few percent CO2 coming in, and we can extract higher than 95% CO2 permeating through it, so by one step. So it's a very compact, effective system to capture the CO2.
I'm Fan Wang, and I'm PhD candidate in Chemical and Biological Engineering department in University at Buffalo. The impact we're trying to make is to see we can capture as much as CO2 with as low as possible the CO2 capture cost.
The technology is different in the sense that it has the cost effectiveness and it is scalable as well as energy efficient. The other techniques like solvent techniques as well as adsorbents use energy, and that is something that we don't want to use as much as possible. And that is where our technology comes in, and we try to efficiently remove CO2 without actually adding to the carbon footprint.
At some stage, you have finished the proof of concept of your technology, but still it still has risk for the investors or industry to get involved. In that stage, I think the TAF funds can make the bridge into the next stage to de-risk our technology and attract further funding support from different sectors. If you're interested in our technology, you can look at our website or contact SUNY Research Foundation.